In this video, we'll graph logarithmic function log of x plus 3 with the base 2 plus 2. So I'm going to use parent function of logarithmic function. The shape look like this, okay? The shape look like that, like this, okay? And I will move it. Translations. So I'm going to use transformation rule for finding the graph. So let's start with the transformation. Because of x plus 3 inside, what happened to the new graph? It's moved, right? Where does it go? Left or right? Left 3 units. You see plus 3, but we go backwards, okay? And outside of the logarithm, without x, this is with y value. Where does it go? That's right, this is moving up 2. So that's the transformation. And let's think about vertical asymptote. We have vertical asymptote at x equals 0 from the parent function. Because we are moving it to left 3, it is moving left 3. So instead of having x equals 0 here, I'm going to have vertical asymptote at x equals negative 3 like this. Make sense? How about horizontal asymptote? There is no such thing, horizontal asymptote here, okay? We have only vertical asymptote. So think about horizontal asymptote for the exponential function. We swap x and y and we can rotate it, and now we have vertical asymptote for the logarithmic function, okay? So make sure you understand that. And in algebra 1, with horizontal asymptote. In algebra 2, you can touch this, okay, vertical asymptote. So exponential function was taught first in algebra 1, and now we are doing harder one, okay? Algebra 2 has, logarithmic function, there is a vertical asymptote. And now let's use numbers, and I'm not going to use all the numbers, okay? I want to plot the points on the corner of the grid so I can do easily. So let's see which one can be plotted. Can I use negative 3? No, this is not a point I can grab because there is a vertical asymptote. So this is undefined. Am I plugging negative 2.5? Oh, I will get decimal number. I will not use this. I will skip it, okay? How about negative 1? Can I plug a negative 1 here? Yep. If I plug negative 1 inside, negative 1 plus 3, that's logarithm of 2 with the base 2, right? And then you will add 2 after that, right? I calculated negative 1 and 3 inside. And that's it. So what do I get? Log with the base 2 and 2, what is the result? The meaning of this is, what's the exponent over here? So that is going to be 1. 1 and 2 together makes 3. So we can plot the point, negative 1 and 3, negative 1 and 3, like that. Okay? Negative 1 and 3. And now let's plug 0. 0, you plug 0, and then 0 plus 3, that's 3, but it's not multiple of 2, and it's not going to be an integer number. So if I use calculator, I can get approximations, but if I don't use a calculator, I do not get exact values. So it's not a good point to graph, okay? Let me skip. Can I plug 1 here? Yes, and then I will get log of number 4. 1 and 3 makes 4, and 4 means 2 to the second power, right? 2 to the second power, so we get the value 2. The meaning is you have log with the base 2, 2 to the second power. This is exponential function. This is inverse function of the exponential function, logarithm function. So bases are same. You can think about, oh, this will be reversed to each other, undo process. So you get output as just initial input. That's why I get 2. 2 plus 2, that is 4. So I'm going to plot the point. This ordered pair gives me 1 and 4, 1 and 4. Now let's plug one more point. Number 5, can I plug 5? Yeah, let's see. Log base 2, 5 plus 3 is 8, right? 8. 8 can be written as power of 2, 2 to the third power. 2 to the third power and log 2, they are inverse to each other, so we get result as 3. Power, which is exponent, or in other words, that's logarithm, okay? So 3 and 2 makes 5. So I can graph this point, 5 and 5 right here. And I do not know other points exact location, but I will connect them like this. And then the other end will follow the vertical asymptote. So you can exaggerate like that and draw two ends with the arrowheads, okay? So that is the logarithmic function. Now let's see, we can answer question A, yes we did, B, yes, and C, let's talk about domain. What is domain of this function? What is domain of this function? X cannot be any value on the left hand side from this line, right? So X must be greater than -3, that's the domain. What is range of this function? Range is possible y values. Look at end behavior. It goes up, up, up. It goes down, down, down. So all real numbers is the range. So make connections from exponential function. Exponential function has domain or real numbers. Now, its inverse has range or real numbers. That's question C. Question D, let's determine the end behavior of the function. So let's write it. As x goes to infinity, look at the right end. Right end goes up, up, up. So y goes to infinity. Or you can use function notation g of x instead of y. Now let's describe the other end, okay? X is heading which number? One number, -3, right? So that's -3. And y goes to down, 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 -infinity. And let me add one little notation from calculus, okay? This x value is coming towards -3 from the right-hand side, so we put plus sign after the number, and that tells us the direction, where it's coming from the right-hand side, because there is no number from the left-hand side. So that is one direction to that number. So -3 is the number, negative is the sign of the number, and the plus sign after that, and that tells us from the left. We will use that notation in the future. Don't worry about it if it confuses you, okay? But you need to know when x goes to -3 from the domain, y goes down, down, down. So be careful when you graph with the calculator, okay?